All right, so we're looking at part B here. Describe a type 1 and a type 2 error in this setting, which is more serious. Explain. So I'll let you, if you want to pause the video and read the scenario. But basically what's going on is we have these two proportions. This is the first proportion. Um, and we're looking at people that take aspirin alone and the incidence of strokes, and people that take aspirin and this other drug, dipyridamole, and have strokes. So we're looking for a significant difference between the two. It's important that you understand what this test is testing for. So we have to talk about, if we're going to talk about a type 1 and a type 2 error, we have to talk about what are the null and alternative hypotheses. First, the null hypothesis would be, is there a difference between these two proportions? So difference between P sub A and P sub AD. Null says no difference. Alternative says there is a difference, and in particular, if you read the context, it says that this proportion here is going to be smaller than the proportion that just take aspirin. So in other words, if you take aspirin and this other drug, there's a lower incidence of strokes than if you just take aspirin. So in this case, we would be checking to see if this is greater than 0. It's a one-tailed test, but these are our two hypotheses. So if we run these tests, a type 1 error would be defined as a false positive. So what that means is the test comes back and says that our null hypothesis is wrong. There's something different in the particular scenario compared to what we're measuring. And when actuality, the null hypothesis is correct. So there is no difference. So one more time, a type 1 error means that our test says that the null hypothesis is incorrect. So there is a difference, when in actuality, there is no difference, and the null hypothesis is correct. So what does that mean within the context? Within the context, what it means is this. Our test says a null hypothesis is not correct, means this. Our test says that patients taking aspirin and dipyridamole have a lower proportion of stroke. So it effectively says that if you take aspirin and dipyridamole, uh, the likelihood of you having a stroke is lower, when in actuality, this happens. There is not actually a difference in the proportion of strokes between aspirin-only patients, which is the one group, and patients taking aspirin or dipyridamole. So it effectively says um, a type 1 error would be, we ran our test. Our test says that this group was better. So taking aspirin and dipyridamole was effective in reducing strokes, when in actuality, there was no difference. A type 2 error is a false negative. And what that means to us is that our test says our null hypothesis is correct when it's actually incorrect. So within the context, what that means is this. Test says that taking dipyridamole with aspirin doesn't reduce the proportion of stroke in these patients, when it actually does reduce proportion of stroke relative to those patients that only took aspirin. So ultimately, they want to know which is more serious. So the first one, type 1 error, would essentially be would essentially say that taking dipyridamole does make a difference, when it actually does not make a difference. So it would lead to more people taking medication that doesn't work per se. Type 2 error would um, basically say that dipyridamole works, but the test says that it didn't work. So you found a quote unquote helpful, not a cure, but you found something helpful for strokes, but our test says that it wasn't helpful. I would say that the type 2 error would be a little more serious, because you've actually found something that could be helping people or helping reduce the number of strokes. Um, and our test basically told you that it didn't. So I would say type 2 more serious, and for those stated reasons.